Okay. Yeah, just a little bit of background about myself. I came from Poland when I was 10, and I was always asking myself how to use technology to make a better world, and the farther I went in the education, the more useless I felt. So the last year of the PhD program started open source ecology. That was actually a response to, we had some hot stuff in the stuff that we were working in fusion energy, and I couldn't talk openly to others. And I thought, what a waste, I can't really get the full value of my education here. What if we could actually cooperate to, collaborate to solve real issues? There's a lot of important issues to deal with, and the open source ecology, the concept of open sourcing critical infrastructures of civilization to make it more affordable, sustainable, regenerative. That's the name of open source ecology. So we're asking this very basic question regarding post-scarcity. Okay, how do we reach a world where material constraints are no longer the dominant driving force of our civilization, like resource conflicts, or in our personal lives, the fact that we have to work so hard with ever-increasing technology, we work harder and harder, have less time for ourselves. Did something go wrong in this picture sometime? So we're starting an on-the-ground experiment at Factory Farm. We're in Missouri. We've got a 30-acre facility, and we're asking this question here. Okay, what if we took all that civilization has learned to date and tried to make a better world? Well, we start building resilient communities, and the concept is, right now we rely on global resource flows to power up our entire lifestyles. But let's ask this question: what is the smallest scale at which prosperity, that means survival and thriving, can happen if we want to go smaller than a global scale? How big is that? Is that a bioregion? Is that like a city area? Like, how about even as small as a farm? I mean, that's the name of our experiment. We're trying to see how far we can go on a single piece of land with local resources. And we claim that it should be easy to do so if we do things right. So to provide our quality of life, we have to start with the needs that we have and the transformation of resources to meet the needs. And it starts with energy. So here, what I'm showing is solar concentrator electric technology right here, which is a feasible technology. It's like power plants like this are coming up in the Southwest and actually in Spain and other places. So what you see here is mirrors reflecting solar energy onto these linear concentrators, linear receivers. You're boiling water, generating steam, spinning turbines, and generating electricity. So with this example, what is, did you know, well, let's ask you this. How much area would it take to power up all of the US energy needs if we use this existing technology? What's the answer here? The answer is 0.2% of the land cover of the United States. So in principle, we've got abundant energy. So now we take the concept of open sourcing technologies, which is what we do for a living, and one of the byproducts of open sourcing, meaning collaboratively developing and publishing plans for all kinds of different things. That's open source economic development. It's based on the Linux open source computing stuff. We're extending that into the production of real physical goods. Well, the typical cost reduction when you open source something, it becomes much more cheap, much less expensive, like a factor of 8 that's typically observed. So what would happen if a technology like this were to be like 8 times cheaper? Well, then you can possibly guess that this technology would be feasible just about anywhere in the world. Like if it's 1,000 watts a square meter in a desert, you might get like 500 watts a square meter here or in northern Maine or something like that. So in principle, this could be a technology that's feasible anywhere and also on a home scale. So what does energy allow you to do? It allows you to process various natural feedstocks into the substance of modern civilization, like take ubiquitous clay. You can smelt aluminum from it. Clay is aluminum silicate. Or take ubiquitous sand, silicon dioxide. You can refine it to silicon, which is the digital age. So What I'm showing here with this is an example of Kennecott copper mine, a couple of miles across. Did you know that you can do the same thing in terms of extracting copper and purifying copper? I mean, you can do a desktop scale experiment to do that. So all these things can be done on various scales if we have energy and the know-how as far how to do that. We have amazing technology available today. It's like the Star Trek replicators here. This is an example of the open source 3D printer, which is called RepRap. It stands for Rapid Replicator, something to that effect. But it prints 3D objects in plastic by depositing strands of molten plastic onto each other. You can make things like plumbing fittings and cases for electronics, or plastic shoes if you want to, or something. But the concept here is this kind of technology would cost you like $10,000 to $15,000 a few years ago, before this open source project came about. And after this came about, you can download the plans for this device and build it for $400 in parts. So that's an example of pretty amazing cost reduction that's feasible with open source development. So here's on to the Global Village construction set, also known as the Resilient Community construction set, depending on which audiences we use, but we're sticking with Global Village construction set these days. That's a good name. Before I go into all that it includes, let's look at a little video to show what kind of work we're doing on the ground.
Open Source Ecology is a network of farmers, engineers, and supporters that for the last 2 years have been building the Global Village construction set, a set of the 40 different machines that it takes to create a small civilization with modern-day comforts. The Global Village construction set is like a life-size Lego set in which motors, parts, and power units can interchange. Thus far, we have prototyped 8 of the 40 machines and have published all of the 3D designs, schematics, instructional videos, and budgets on our wiki. The cost of making or buying our machines are, on average, 8 times cheaper than buying from an industrial manufacturer. The compressed earth brick press is our first product release and is the world's first high-performance open-source model. This machine allows one operator to load raw dirt right from the building site. The MicroTrack walk-behind tractor is a perfect solution for small-scale agricultural uses or where land features require a more flexible tool than a full-size tractor. The front mount allows attachments for tilling, mowing, and chipping. The LifeTrack multi-purpose tractor is the backbone of the Global Village construction set. The LifeTrack combines the power of a skid loader with the functionality of an agricultural or construction tractor. This year, we also completed prototypes for our drill press, self-replicating torch table, string trimmer, and soil pulverizer. As you can see, we've got a lot more to do.
Okay, that's a picture. What we have there is a picture of the work on the ground. We've done some interesting work already. So to get back to the presentation, okay, let's go back to this one. Okay, so what you've seen is a life-size Lego set for constructing real hardware, like the whole infrastructure, like the tractors where parts interchange. You can interchange the power units between things like the tractor, the car, the bulldozer, and tools like drill press or lathe and stuff like that. The motors can also interchange, so it's just hyper-modularity, radical hyper-modularity in design, lifetime design, where bolt-together construction allows you to totally maintain it. We're designing it in absolutely the simplest way possible so that the human is totally in control of their technical equipment base. So we've got things, the whole agricultural construction infrastructure, things like cars, tractors, combines, haying equipment, solar concentrator, electric power, modern steam engines, pelletized biomass for fuel, means of fabrication, and other things like bakery, dairy, nursery, and some other essential items for a community. Okay, so this was the first prototype of the tractor that we did, LifeTrack, life as in lifetime design. This is an example this is the torch table that we prototyped. It's our first version. And with this thing, you can put all the metal that you would need to construct a thing like the tractor and cut it out so that the production time for a tractor, like you've seen, could be actually under 1 week. And this table itself is also designed such that with this table, you can cut out the parts for another table like that. So it's one of these self-replicating machines that, because of the self-replication, allow you to produce very, very effectively, very low cost. This is the second prototype of the tractor. You can see the very basic design. It's like a box with wheels, and power unit goes on top of that. We added the tracks to that for extreme traction. And this is the soil pulverizer for pulverizing soil, for compressed earth brick press construction. And you can see things like, for example, that hydraulic motor. That's one of the interchangeable parts that you can put on another device to power something else. This is the 150-ton hole puncher, which allows you to punch holes in 1-inch metal, up to 1.5-inch holes. And so that you don't have to be drilling, which takes you a minute or two. You can punch a hole immediately in a second for rapid fabrication of things. So it's about creating very efficient tools of production in a set. And this was the second prototype of the compressed earth brick press, the full product release. And the concept here is it's a fully automatic machine, and just one operator with a tractor and a salt pulverizer can load this, and that's enough to press bricks, and they slide out the other side of the machine. And the machine is also, there's an electronic controller in there that also builds on other open source projects, so you can take a look at those plans. It's all documented, and in principle somebody with basic skills could end up putting one of these together. And right now it's taking us about a week to produce these things. And they're largely designed for disassembly, like bolt together construction, so you can crate this up if you want to ship this thing. This thing stands about 7 feet tall. You can compress it into like a 3x3 by 6 foot box for shipping. And this is the kind of structures we're beginning to build, modular CEB construction, where you start with the columns and you can infill any kind of wall you like, either single wall, double wall with insulation, like hammer milled straw for insulation or something like that. You can also make things like housing with the same construction system. So we're experimenting with this novel way to build modularly with masonry, which is the bricks that we're making. Here's another important point, that the open business models are actually working. What we do is we actually share the plans not only for the machine, but how we produce it, so that other people can replicate this enterprise. And on the compressed earth brick press, the material costs are actually about $3,000. We're selling the machine for $8,000, and the competitor with the closest machine would charge you $45,000. So there's an amazing efficiency that we have in our ability to produce by eliminating all the types of waste that go into product development, like the proprietary development costs and a lot of other forms of waste. And then RepRap, that open source printer I mentioned, that's shown very much amazing forms of cost reduction as well. So we can be talking about potentially post-scarcity levels of production. The concept where we're now taking ubiquitous resources that are all around us, and by building the technology set that we have available on a local community scale, we can meet real needs with, for example, construction materials right from the building site, like this compressed earth home here. It's an example of the kinds of things you can now build if you have the technology to do so. The Global Village construction set includes just about all the tools we have for building resilient communities, from agriculture to fabrication, energy, housing, and so forth. And if this thing works, it could spread virally. If it relies on local resources, it's we call it the resource-based economy, where now instead of using funny money, you're using real resources around you to generate the wealth of your community. That's the point of this game. And also another side effect here is if your community is using its own resources from the immediate environment, there's a natural feedback that will check populations of people, i.e. if you're crushing your environment, you're not going to overpopulate because you see that immediately around you, as opposed to all the things that you use coming from global sources where you have no idea, you know, when is enough, or is there any shortage of something. You don't know that. So by using resources locally, you can have a much better control on the population explosion issue as well. Here's a picture of an army of combines going through thousands of acres of soybean field harvesting. Well, that's the kind of stuff we actually have to compete with to be efficient. With our tool set, we might not have to do that, but perhaps an operation 100 times smaller in scale, where now we're using our local resources for local communities to generate local wealth, so for relocalization. But we do have to be competitive with the traditional sorts of things that go on there in the mainstream economy. We're also not calling for any doomsday scenarios here. We're talking about doing things better with things like lifetime design, which gives you like a 10-fold factor of efficiency right there when some object does not break after 5 or 10 years but lasts 100 years. You know, that's a big impact right there. We talk about neo-subsistence as a concept where you can produce for outside markets if you like to, but if you can produce for your own communities, you don't have to. There's no longer that pressure to get into trade or to work for the man or whatever, or cause war, because you can actually fend for yourself. So this is a way to take care of your neighbor if you're able to provide for yourself. And what we're calling for is Industry 2.0, a different kind of production system where flexible fabrication is now the means of production, meaning that you use much more human skill and generalized machinery to produce a wide range of products, as opposed to extremely specialized machinery and dumb human labor. So that's the flexible fabrication concept, which could ultimately lead to autonomy for you and me. And here's the part about the open source fabrication concept. What we have this doesn't show all the tools, but we've got things like the torch table, which I mentioned, for cutting out steel, the 3D printer, multi-machine for milling, lathing, drilling. Big part is an induction furnace for melting down metal. So in principle, you can take the scrap streams of metals from society, industrial detritus, and convert it back into virgin steel for the things like the tractors and CEV presses and everything else. And in the whole set, we've got metal rolling to generate virgin steel, like wire drawing to make bars, shafts, wire, rebar, sheet metal roofing, and forge, and welding, torching, plasma cutter, not shown, industrial robot, such as a robotic welding arm for doing other things that a human might not want to do. So mixing an appropriate base of automation with high human skill to produce just about anything, including electronics, like with a CNC, computer controlled circuit fabrication, little mill for doing that. So we can put together a pretty robust set of tools to produce just about anything. It's the Fab Lab concept that you might have heard about, that originated at MIT. But let's open source all those tools and then enable local communities to produce locally. The model being that in the flexible fabrication scenario, you've got people who can generate design globally. Everybody can create designs like the CEV press, the tractor, or whatever else. You can share that globally and then produce locally in your community. So that's the vision of the distributed manufacturing that's feasible in today's world. But this is not about technology. It's really about humans becoming more integrated, aligned with their true values, reconnecting to ourselves, to nature. And we say that technology should in fact be a way to reconnect to nature. If you're using your local resources to feed you by the use of technology, then you care for your local environment and you drive to make it better, not to destroy it in a global system where the accountability is not there because of scale and just all kinds of global flows. So we can take care of nature and have technology be a part of that. That's that. Okay, but we're about halfway done. I want to tell you a little bit, another story about lifestyle issues surrounding this. So, here, let's go to, oh, okay. Here's the next deal. Did you know it costs you about $1 million to live just to provide your housing, cars, and food, your transportation, your wheels? Over a 78-year average lifetime, that's what it ends up costing. Can we do better? Okay, that's business as usual. What about this? What if you were to invest in an entire infrastructure that can get you to all the things that you need? How about if you spend that, like right there, that's not a mistake, it's like 0.02 million, like $20,000. How do you do that? Let's say you got 10 people at 20K each, you get together, say $200,000, and build in the entire infrastructure, starting from land, and all the productive equipment that can get you to do that. The whole point of that being that if this thing is providing full resilience, that means all the needs that you have, then your cost of living goes drastically down if you value your freedom as opposed to having to work for the man. Okay, so what if we tried to do this in the mainstream industrial economy right now? Well, first you'd pay more. Like if you didn't have the open source tools, which you could build, if you go to the store, go to Northern Tool or whatever, to your industrial provider, it'll cost you like $900,000 to build the same thing. Well, that's not too bad, but the problem with it is that if it's all this proprietary closed source equipment, then these things break down, and the maintenance costs in the long run end up killing your operation. So it becomes literally impossible to keep up with the costs of maintenance. You need expensive repairmen, expensive parts, and so forth if you don't have the control of this technology. And just to give you an example of what happened to us, we built the tractor initially out of need because the tractor we had, it broke, the transmission went out, we paid $2,000, and then a month later it went out again. And we said, no way, this is sinking our operation here, we're going to take care of that, design some open source equipment, and that's where LifeTrack was born, LifeTrack for lifetime design. Where the worst kind of problem that can happen is a $250 replacement of a wheel motor, for example. Everything is designed such that it's absolute controllable, low-cost parts, widely accessible stock steel that you can get anywhere. The assumption here is still that we need skilled people to do this. Instead of paying that 900K, if we have a skilled bunch of people that can actually produce the entire set from scratch, then you can drive the cost way down. Okay, so what we're planning on after developing this whole package of 50 or so tools, we want to educate people how to be producers. So a lot of this is technology, it's both technology and agroecology concepts. So let's talk about immersion training, practical hands-on training, where instead of say, I don't know how you guys feel about your 4-year education here, but for I wanted a refund because I didn't learn the things that I needed to learn. So what we plan on doing is actually creating an education system where you learn the real skills of how you can actually survive and thrive without dependence. I mean, for me, that's immensely valuable, and I think there might be more people that would really like that. So that's what we plan on doing, immersion training. So if you have skilled people and all the different tools of production you can replicate the entire set at minimal cost. Like, especially if you have the induction furnace down there, then you can be generating steel or metals and processing them to build all the things, literally at the cost of scrap steel. But then, at the end of the day here, we still don't burn down the cost to zero, because there's all these things like rubber O-rings and plastic or glass or other things that are still not provided in the set. So why not? Can we do better? Yeah, I mean, right now all we're doing is taking parts off the shelf and building the things that we do. The next step, of course, is to build the parts for the things, like the hydraulic motors or steam engine power units, renewable energy equipment, everything else. We got to start going down to making the parts that go into our system. And at the end of the day, we end up working on materials. So things like dandelion root resin that can get you rubber. That's a commercially proven process. Or the extraction of aluminum from clay. That's also real. The figures there are wrong, but we found out that about a 6,000 square foot facility for producing aluminum from clay, and I'm talking about dirt under your feet that can be used to make bricks or aluminum. That's what we're talking about here. 6,000 square foot facility produces 2,000 pounds of pure aluminum per day. So that kind of technology exists today. We can do that, and we think we can put together a facility like that, a prototype, for about $50,000. So just crazy examples of the insane level of technology that's accessible today to use local resources in a totally novel way for total resilience, for totally ecologically integrated communities. Okay, and this is kind of the Energy 101 slide here. This does boil down to energy access. And the baseline we have to work with is 1,000 watts per square meter that comes from the sun. At Factory Farm in Missouri, that can get us 4,000 pounds of dry biomass crop sustainably per year, per acre. And that's just grass crop, pelletized. What we're assuming there is that we will develop steam engines, modern steam engines, which, by the way, have now become more efficient than internal combustion engines through recent developments. You can look up Cyclone Power Technologies if you want more information on that. But, okay, for the energy that we get from 1 acre, we can go, if we have a 50 mile per gallon open source steam engine biomass pellet fueled car, we can go across from LA to New York 8 times. So the energy is there. Now, biofuel is rather inefficient. I mean, well, you can call it very efficient from an ecological standpoint, but it definitely doesn't get you as much as direct solar conversion by things like solar concentrators, which are much, much more efficient than that. You're talking about 10% efficiency for the conversion of the 1,000 watts per square meter. But in any case, if we look at what does an average person consume in the United States, it's about a kilowatt, actually kilowatt per household. That amount of energy can be generated from about 1/100th of an acre if you use the solar concentrators. And for the total industrial output that we use, which averages 7 kilowatts per person, like to produce these chairs in this room, this building, roads, buildings, cars, everything that you use, that takes about 7 kilowatts per person. And if we use the solar concentrator electric power, which is one of the key things that we want to open source to make it feasible just about anywhere, you're talking about a fraction, like a 1/15th of an acre per person to provide all that energy that we need for that. And that's considering the wasteful system that we have today, which doesn't consider lifetime design and good design principles that you're being all taught about here. So we can do better than the 15th of an acre that we do today if we use the solar concentrator electric as the means to get our energy for all the industrial processes. But the conclusion here is pretty radical. What we're saying here is that advanced material civilization can be produced on the local scale using local energy. So that's a pretty big claim. Our humble experiment in the fourth year of its infancy is trying to show that you've seen what we've gotten. We've got a long way to go. And our present plan right now, our present plan for one is to build production capacity. Like this building here we're planning a 4,000 square foot facility to produce things like the tractors and CEB presses and since we've gotten the CEB press down to like a week of production time, that could translate to $5,000 per person per week in earnings. So the earnings could be significant if we have the marketing ability to do that. So we're trying to bootstrap the revolution here by the product sales. And also we're trying to build up our infrastructure for housing, to house people for dedicated project visits and collaborators on site at our place. So to summarize, we've shown this interesting Lego-like construction set for building the infrastructures of communities. We're showing that the economics of this are actually working out, and that replication can happen at very low cost. So where we are right now is, after the 4 years at Factory Farm, we're basically regrouping and reorganizing for rapid parallel development. We've gotten just one full product release. We've got way to go. And we're looking to gather, through the nonprofit sector right now, like $2.4 million over the next 2 years to finish the entire set of the 49 remaining items within 2 years. So we're talking very quickly in rapid parallel development style, where we tap project managers, subject matter experts, prototypers, developers, designers, and fund them and pay them to do the development work and go from there. So that's we're trying to do this with the nonprofit sector through the earned income, and also through True Fans, which is a subscription where people pay up like $10 a month to support this important work. So I encourage any of you in here, please subscribe to that if you can, to help this work go further. So yeah, it's totally exciting. The autonomy for people is the final reward, in my view, in terms of what I'd like to get out of it. We're just trying to basically get the set of tools available, make it available to anybody, and the applications are just endless. You know, from the developed world to the developing world. You know, flexible fabrication facilities, reinventing production, local production anywhere, local CSAs or community supported agriculture / manufacturing operations, and just all kinds of local relocalization. So that's all kinds of applications are possible. So you can look up more of our work at openfarmtech.org/weblog.